Hello, everyone. Surprise, surprise. We kept our
Welcome
promise.
back.
Yeah, indeed. It's only 1 week from the previous episode, and we already have another one. So, yeah,
Yeah,
surprise.
we have like a tight schedule for 2024. So,
Yeah, indeed, indeed. No, we promised this because last time we did. So we started the new year talking about AI from a very practical perspective. So integrating AI in applications. And we introduced the topic of Semantic Kernel, which is an orchestrator built by Microsoft to simplify these integrations. But as me and Mark we were talking, we realized that probably it was too much to fit into a single episode. So if you want to know more about Semantic Kernel, catch up with the previous video. And today we'll take it from the end of the previous video, and we'll start talking about memories. So managing memory in Semantic Kernel. And Mark will today. Mark will help us also to understand more how, in some scenarios, we can compare semantic kernel with LangChain. Again, if you missed the last episode, you'll know. If you watch the previous episode, you'll see that you'll understand that myself has made quite a good experience with semantic kernel in the past months, while Mark experimented a lot with LangChain. So we can see the two sides of orchestration with two different technologies.
yeah, so it's basically the two big, well, I don't know if you can say competitors, because LangChain is pretty widely used even within our employer. So it's not like that we see this as like two different tracks and direct competitors, but rather probably completely different use cases in that regard. But
yeah, different use cases and also different targets. I think we mentioned this in the previous episode. There are many, but one of the main criteria that you can adopt to choose which one to pick is the language and the platform you prefer. Because if you are a Python developer, LangChain is an excellent choice. But if you are a C#.NET developer, you don't have the option to use LangChain. And as such, semantic kernel becomes your main options on the market to do orchestration. There are also libraries. For example, there's an OpenAI .NET wrapper around the OpenAI APIs. But as we have seen in the previous video, semantic kernel is much more, generally speaking, orchestration frameworks are much more than just an abstraction of the APIs. Last time we saw function calling, planner, plugins. So there's really much more. But let's not waste.
Wait a minute. Let me just bring this up, because this is actually a good point that you're bringing here. You're not actually you're not actually required to use LangChain or semantic kernels. So if you're just looking for some easy templating, for example, there's definitely no need to go for the full framework, because this is something you can easily do with your own coding and some REST calls, and then you end up with a library that is much smaller in size, with a smaller footprint, and so on and so forth. But the moment you start changing things, you want to add memory. I mean, all these things can be done if you're a programming rockstar. You can do these things on your own and maybe bring up a third or a fourth competitors. Insert random XKCD comic here. But other than that, I mean, obviously, if you just want to get stuff done, that is probably the best use case here for using LangChain or a semantic kernel, or even combine both. Why not? Although that doesn't make too much sense because the overlap is too big.
Yeah, indeed. So let me share my screen, and before we start talking about the scene code and demos, I wanted just to make an overview of the problem we are trying to discuss today, which is So in the last episode, we have seen how Semantic Kernel can help with many scenarios, like integrating third-party services into the AI workflows. But another very common scenario when you are building a custom application powered by an LLM rather than just using ChatGPT or Copilot, it's because you want to enable scenarios. We call them typically chat with your data. So using the natural language, the power of the natural language and the generative AI offered by LLMs, but with private data, with, for example, your organizational data, which is something that instead, remember that LLMs are trained with public data. So they can't answer questions about data that comes from your organization, because hopefully it shouldn't know this information. It shouldn't have access to this information. So there are multiple ways to enable this scenario. One of the most commonly adopted in the industry is called the Retrieval Augmentation Generation, which in a very, very short summary, it means that you ask a question to the LLM, and from this question, you generate a search query, and then you use this search query to go into your database, your library, wherever place you have your data. You retrieve all the documents, text that can help to address the question of the user, so that match the search query. You add them to the prompt, and then what you send to the LLM is a bigger prompt with the question of the user and also the data that should answer the question of the user. Then the LLM takes everything and it's able to reason over the information you have provided, and it's going to give you an answer if in the information, in the text, in the content you have provided, there are enough information. This process, so the advent, or to be more precise, they already existed, but now they are becoming they became more relevant. So the introduction of vector databases, because if you think carefully about this scenario, you quickly realize that the weak point of this implementation is not really the generation of the response, because we all know that LLMs have very powerful capabilities when it comes to managing natural language, but the real weak point is the search. So if you don't provide to the LLM enough and good information to answer the question, you might get hallucination, better responses, I don't know, and stuff like that. So to make this experience better, the industry have adopted the vector databases, because vector databases are a way to enable what we call the semantic search. So instead of searching in my database only when there is a match between, for example, the title of the document and the keyword that I provided, we can do a search by similarity. So when we are talking about a topic that is connected to the question of the user. This slide shows you an example. It's an approximation, but just to give you an idea, the vector database is a sort of a multidimensional space, and you can see how these two group of words are clustered together because they are talking about the same topic, which is food. And some of these words are even closer together because the relationship between muffin and donuts is stronger than the one between muffin and lobster. They are two different types.
Who doesn't like some meat donuts?
Yes, or maybe having breakfast with lobster. I mean, could be an interesting experience. So, I mean, who knows?
We're not being paid enough to have breakfast with lobster, but yes.
Well, here I can put, I don't know, not really German side, but we can talk about the North European side. I remember my close friends from Netherlands that he ends up his meals with a cappuccino. So we can connect coffee with meat, I don't know, or with lobster. Why not? So joking aside, you can understand how this type of search can really improve the quality of the results, because basically what happens is that you take the search query, you turn it into a vector, and then you grab all the vectors that are similar to the search query. So an example, I'm looking for information about electrical cars, and with this type of search, I'm able to pull up documents that are talking also about battery or sustainable energy or other topics that are related. How do you get... Yeah?
Sorry.
No,
although it's important, just it's kind of like the bridge back to one of the early sessions we did last year on the LLMs. It's not like that the words are being stored. Again, it's the token that are being stored, or the token ID and the vectors for that. So if you haven't seen this episode, one of our first, somewhere back in the archive. So keep in mind, it's not the words or the images. It's, as Matteo wrote out there, it's either pixels or tokens.
Yeah, correct. That's a very good point. And in fact, my next point was that here in this slide, to simplify the explanation, you have text, you have words, but in reality, you have vectors, and these vectors are generated using AI models, which are called embedding models. And by the way, yesterday there was an announcement from OpenAI that they have released a couple of additional embedding models that are able to generate embeddings which takes less space, but they have better quality. So it's a very interesting, but I haven't explored it yet because it's an announcement from yesterday, but it's something they released yesterday. Having said that, you realize how implementing the retrieval augmented generation is not super straightforward, because you have to build an orchestrator, so something that takes care of taking the prompt of the user and generating a search intent, then doing a search on the vector database, then combining the user prompt with the information gathered from the document, then send the prompt to the LLM. Moreover, it's not something that you do continuously, even if it depends by your scenario. For example, if I think about M365 Copilot, this happens continuously because data and documents keep changing. But anyway, to set up your application, you will need also to take care of converting your data into vectors through the embedding models. And additionally, we typically, when you are implementing this type of scenario, you also implement chunking, because remember that one of the limitations of large language models is that they have the prompt can't be unlimited. And even if it was unlimited, based on how OpenAI and Azure OpenAI work, the longer is the prompt, the more expensive is the request, and the longer is the time needed to generate a response. So with chunking, basically you split longer documents into multiple parts, so that it becomes easier for the orchestrator to give to the LLM only the pieces that are relevant. Because otherwise, if you have a 200 pages document and you store it as a single vector, it means that you ask for example, let's say that it's a document about the HR policies of your company. You ask a question about one policy, and you have to send 200 pages about 1,000 policies. So with chunking, you can improve that. So a lot of work and a lot of things to do. So Microsoft, with the goal to help you simplifying this experience, have implemented a project called Kernel Memory. It's a service by Microsoft that you can use to simplify the whole scenario, the whole implementation I just shared. So it takes care of taking your content and generating embeddings, and it supports also multiple types of content. So you can index a text, a file, a website. It supports storing them into a vector database, and then behind the scenes, you connect it also to an LLM so that you can chat with your data. The philosophy behind kernel memory is similar to the philosophy behind semantic kernel, because if you remember in the previous episode, one of the advantages of semantic kernel is that just with extension methods, you can switch from Azure OpenAI to OpenAI to Hugging Face in the latest builds. Similarly, in kernel memory, you can switch to multiple providers for the LLM and the embedding generation, and to multiple vector databases for storing your data. So, coding time, let me show you an example of kernel memory. And in this case, so all the examples that we did in the previous episode were based on a terminal application. Here, I switched to Blazor because I needed a little bit of UI to interact with the user. And this is how you set up the kernel memory experience. It's very similar to the one you have in semantic kernel. So you have a kernel memory builder, and then you have multiple extension points that all start with that you can use to register multiple types of services. You can provide queues, you can provide LLMs, you can provide vector databases, and so on. For example, here I'm setting up the only requirement, and this is different from semantic kernel. You have to provide at least two types of models. The text generation one, which is required for the natural language generation, for example, when you ask a question, and the text embedding one, which is the one used to generate the embedding. And then you can provide a vector database for testing purposes. There's one embedded called the Simple Vector DB. That it's very useful for testing because it stores the vectors in memory or on disk. But for production scenarios, you can also do better and use more production-ready services like Azure AI Search, Quadrant, and others.
But following the motto of our little podcast here, we always use in memory, even on production.
Of course, yes, of course. So that's incredibly efficient. Of course, I mean, who needs? You put it on a VM and you just pay. I mean, that's not a big deal. So
yes.
One interesting thing is that you can see here that I have this build memory serverless because kernel memory can work in two ways. In this simple example, I'm using memory serverless, which means that kernel memory runs in the same context of the application where you are using the kernel memory. So in this case, it's a Blazor app. The Blazor app takes care also of generating the embeddings and using kernel memory. If you need instead to support a more scalable scenario, so you want to decouple the two things, you can run this as a service, basically. And then you have a web client that you can use to connect to kernel memory. So everything is the same. So everything I'm going to show you about generating embedding and asking questions works exactly in the same way. And the object is exactly the same, except that it's connecting to a remote instance instead of running it locally in the same environment. Generating embedding is incredibly easy because you have one method for each supported type. So you have text, import text async, you have import document async, and you even have import web page async. So basically it will scrap the page and index everything inside the vector database. And then if you want to chat with your data, remember all the architecture I shared with you before. So generating the search query, searching for documents, putting them in the prompt. This is all replaced by this method, ask async. Ask async will do everything for you. And you also get back the citation. So you have also the option to generate to see where this information is coming from. So let me show you this up and running. And let me open also my Azure AI Search service. So I previously ran
the new name.
Sorry?
You already adopted the new name of cognitive search?
Azure AI Search, yes.
But
also Kernel Memory was updated for doing that, because
true.
you can see that now it's with Azure AI Search Memory. So they updated the package.
Yeah, true.
So here, for example, previously I have uploaded a PDF. I can show you the PDF. It's basically the manual, the employee handbook of a fake company.
It's the Contoso one. Okay. Did you do the automatic chunking, or did you do all this manually?
Here it is. Yeah, it's so. No, sorry, that's a very good question. Chunking is built in. You can configure the chunking based on how you want to perform it, but by default, it did the chunking. So, for example, you can see that what I provided was this PDF documents here, which is roughly 11 pages. And if I go into the vector database, I can see that it's 4 documents. So it automatically chunked that. And when I look at the content, I can see that I have this is the PDF, so employee handbook PDF. This is the payload. So you can see that we have a preview of the text that was included in the document, and below we have the wall embedding. So this is an embedding, a huge list of numbers inside an array. And all of this was done by simply, in my application, I clicked add content, I clicked the choose file, and what I did was using the APIs of Kernel Memory to call this import document async, providing the path of the document. And once you do that, you can ask a question, because behind the scenes, remember that we registered also an LLM, so a text generation model. So, for example, we are able to ask what is Contoso Electronics, and this ask question, this ask async method will go and do the search query, search on Azure AI Search, finding relevant documents, and generate an answer based on this. And as you can see, you also get the citation. So this is a very simple scenario, but it's a pretty good one. One demo I always make here is that sometimes I'm challenged, or to be more precise, I say before everyone challenges me, that what is Contoso Electronics is not a great example of a semantic search, because this, if we take a look at the PDF document, that the one I share with you with the employee handbook, the mission of the company, for example, starts with Contoso Electronic. So I would have been able probably to achieve the same goal also with a standard keyword search. So what I do is I run a more side question, like is Contoso Electronics a good choice if I need a company that builds things that fly? So it's a very side question, but I think it's a good one to show you the capability of semantic search, because if I take a look at the document, I can't, and I search and I do a keyword search for things that fly, I can't find anything. However, I'm able to get a response, yes, because Contoso Electronic is a leader in the aerospace industry, because what happens behind the scenes is that things that fly is turned into an embedding, and this embedding matches or is very close to the embeddings which represents words like aerospace, commercial aircraft, military aircraft. So I was able, the semantic search was able to pull up this information that the LLM used to generate an answer, while a standard keyword search would have failed this, because if I search in the document for build the things that fly, I don't find anything.
Ask it if it can make good strawberry, if Contoso Electronic can make good strawberry cakes. I just want to understand, because usually the moment you bring your own data, it kind of like ignores all the knowledge it has besides that.
Yeah, my
And now it will
expectation is
just
that it
tell
will
you-
tell, it will say that it doesn't know, info not found.
Yeah, exactly. This is exactly the result I wanted to have highlighted here, because this actually means you can even reduce the surface for prompt injections by just going for BYOD. Oh, well, bring your own device, bring your own data. Well, BYOD in the sense of bring your own data. And yeah, so it doesn't know, and it tells you it doesn't know. I think you primed the model to tell it, like, if it doesn't know, tell it doesn't know.
No, actually, you are. Yeah, thank you for your question, because it's a great segue for the other demo. So in this case, I didn't do anything. So by default,
got it. Okay.
Kernel Memory will tell you info not found if it doesn't find enough information to give you an answer. Because why we are getting info not found instead of no, Contoso Electronics is not a good company, because it doesn't know, because the document doesn't mention strawberry cakes, so it doesn't know if Contoso Electronics is good in making them or not. So if you wanted to tailor and fine-tune these scenarios to have a little bit more complex logic, the next step is that Kernel Memory and the Semantic Kernel teams are friends. So what the Kernel Memory did was building a plugin for Semantic Kernel. And in this case, you can combine what we saw the last time with Semantic Kernel, so the planners, the function calling, the plugins, with the power of Kernel Memory. So here I have set up, for example, Kernel Memory to connect to the same Azure AI search service, so same vector. But here I'm also importing the mail plugin. If you saw the previous demo, this was a plugin to generate business mails. And then I import also the memory plugin connected to kernel memory. And now I can combine the two things. So for example, here I have a prompt saying the following message contains a question and potentially a task to perform on the answer. If you can't find the answer to the question, meaning that inside the LLM you don't have an answer, use the following prompt to ask the question to kernel memory. And by using the special syntax provided by Semantic Kernel, we are asking the plugin to ask the information using the kernel memory plugin. Then I use the answer to perform the task. And for example, you can see that another example here is that instead of getting the info not found, we can say if the answer is empty, say I don't know. Or if the answer is empty, say no. So you can fine tune the type of response you get when you don't have this. And by combining the two, you can you open up a lot of opportunities, because basically you can combine the power of semantic kernel and an LLM combined with your data. So it's not just chat with your data, because in the previous example it was great, but it was only a one-shot thing. But for example, here I can do things like what is Contoso Electronics. Now, since we have the plugin for the memory, and we said in the prompt that if you don't know, use the plugin to search for information. If everything goes well, in a few seconds, we will see some information about Contoso Electronics coming from my vector database. Drum roll. Okay. And for example, since now we are in Semantic Kernel and we have imported the plugin, the mail plugin, we can say, okay, thanks. Now take this answer and format it in a business mail. And now we are into Semantic Kernel with the mail plugin loaded, with function calling enabled, so it's able to automatically use plugins if needed. And now it's going to combine the two things and it's going to if everything goes well, we will get a business mail to share what is Contoso Electronics. See? So, and if you remember the previous video, you remember that the fact that this mail is signed with iAssistant is a sign that this is indeed my plugin, because in the prompt of my plugin, you have the instructions, always assign the mail as AI assistant. Yeah. So this gives you the power to combine everything. Some scenarios I tested before is, for example, I've asked what are the values of Contoso Electronics, and then I asked to format them into a table, or so it gives you unlimited options to do everything you want with your own data. And it's very powerful because you can really implement a retrieval augmented generation experience much faster and with less code than building your own orchestrator. It's a good trade-off because in the market there are many solutions. Also, for example, Copilot Studio from a low-code perspective that you can use to enable retrieval augmented generation just with a couple of clicks. But then, since you are into the low-code territory, the options to customize and do more powerful things are a little bit more limited. Here, you can kind of get the best of both worlds because you have the power of pro code and full code, so you can do everything you want, but you don't need 3 days only to implement the architecture to do retrieval augmented generation, because kernel memory can help you saving a lot of time and complexity. Pretty cool.
Yeah, pretty nice. I mean,
I don't know if you know this. Maybe you know the answer since you are more into the Python world than me, Marc. I know that something similar in the Python world is Llama Index. I don't know if you have any experience with that.
No. Llama Index? No, I'm afraid. So here's the thing. My Python knowledge is... So actually, I have to admit, my Python knowledge only comes from my playing with LangChain, because I still struggle to learn Python. Like, I tried this for many years.
To be more precise, rather than your Python knowledge, I was relying more on your LangChain knowledge, because I've seen on the web that in the same way you use Semantic Kernel is a great companion for kernel memory, because we are in the C#.NET world. In the Python world, Llama Index is a good companion for LangChain for these scenarios.
Okay, but then this would require me to use... Oh, actually, the Llama... Yeah, so I haven't used the Llama one lately, because running this locally is a little bit challenging for the hardware I'm currently running. So... I mean, if someone wants to sponsor me an M3 MacBook, I'm open for these experiments. But it doesn't seem to be. No, but seriously, no.
Well, that's a good task for one of the next episodes. I was taking a look.
Here's the thing. So this is something I've built with LangChain already. I have a Python. So I have used LangChain and the GPT model to build Python for me, and also to build Python LangChain stuff for me, because...
Yeah, this seems to be pretty similar to kernel memory. In some cases, it seems that it's quite powerful, because at least based on the graphic here, it seems that it already comes with connectors for very popular sources. So I see Notion, YouTube, PDF, Slack, PowerPoint.
That's interesting, because the memory concept of in LangChain is slightly different from a semantic kernel, at least from how I understood it. So you have the regular retrievers. So this is completely different. So when you ingest stuff into your memory in LangChain, you usually have your retrievers, in the sense of, I don't know, using archive or PDF documents and whatnot, Word documents. So those are being then used, and then you can create the embeddings out of it and so on and so forth. The memory itself in LangChain, like the one that is built in, is actually just the chat buffer, right? So the conversation buffer. This is their concept of memory. So it's not that it's like getting artificial or extended wisdom or knowledge from, I don't know, Wikipedia or something, but it just relies on what it talked with you about. I mean, so and then you have like the option of either providing the memory, the conversation buffer by synthetically creating question answer pairs, or you use a retriever, create the embedding, and provide this then through the means of RAG, like Retrieval Augmented Generator, and so on and so forth. So this is the concept that is, it's slightly different. So it took a while for me to basically understood, okay, so the memory concept is more like the cohesive memory, like we know it from our brains, like memory is memory and not just what we talked about. As I said, like this is a little bit different in LangChain.
Okay.
But I mean, I assume the Llama thingy is then probably bridging the gap between the retrievers and the regular memory, like the conversation buffer.
Yeah, from the website, it seems, at least in purpose, very similar to kernel memory. So the idea is chat with your documents, build a chat bot around your documents, and things like that. So what makes these tools powerful is that, again, no experience, but based on what I see on the website or based on what I know about kernel memory, they take away a lot of the complexity of indexing complex data. Because in kernel memory, for example, when you import a document, it supports Excel, Word, PowerPoint, Markdown, JSON. So regardless of the structure of the document, it knows how to manage this, how to generate the vectors, how to store them. Doing this manually for all the potential formats you have to deal with, it's not really an easy task. So
I agree. Yeah. And this is something I see a lot with my customers. They're asking like, oh yeah, so I have this documents, they keep updating. They are being updated like once every week or month or whatnot. So they're like regularly updated. And those are not only PDFs, those are, like, as you said, like a variety of CSV files and so on and so forth. And they would like to ingest everything. And here's where Semantic Kernel just like, give it to me. I do the rest. And the good thing is,
there are also tools to manage these scenarios. For example, update scenarios more easily because, for example, when you ingest content, you can also provide a document ID property. And if you keep using the same document ID for the same document, it's going to replace the existing embeddings and not generate a new ones, so that you don't have leftovers from previous versions of the same document.
Another option is, and this is what we did recently, is so kind of like skip semantic kernel entirely, rely on cognitive AI search, and have like the re-indexing of the vector index basically run continuously or run like every day. And since the vector search now can take care, I think this is still in preview, but this feature is pretty nice. So that's why I asked about the chunking thing before, because it also does like the chunking and the equating of the embeddings and so on and so forth internally. So you can kind of like go back focusing on your, and with focusing, my camera unfocused, nice. And now you can basically focus back on your application and the features of your application, and have this like as a separate process of like re-indexing all the documents and so on and so forth.
Additionally, in my demo, I didn't share you all the scenarios, but for example, kernel memory can be connected also to a storage. So instead of your local, in my case, it was the local disk. So I was saving the PDF into the local disk, but you can connect it with Azure Storage, for example. And in case you have more complex pipelines, for example, you have to ingest thousands and thousands of documents, you can have support for queues. either with Azure Queues or with Rabbit to manage the pipeline of documents that gets ingested. So instead of having a for each that is quite rudimental for heavy, intensive scenarios, you can set a queue and let it manage the dispatching of the queue.
This is actually interesting. So it means we have like now both options. So we can have do those things on our own as developers, or we can push this to the service or resource, obviously with additional costs and so on and so forth. Okay, I wasn't aware that this is an option, but yeah, this is great if there are, because obviously if you want to control chunking and so on and so forth, it's better to do this manually and not just let AI search do its thing.
Yeah, additionally, I didn't show you this, but let me I can show you a demo from the GitHub repository. So you remember that I mentioned the serverless option, which is the one I used. But if you want to have this running in a separate service, you spin it up, and then from your client application, you use this memory web client with the URL of where you're hosting the service. Everything else stays the same. So import document, ask async, and so on. But it's not running in the same instance of my Blazor app, for example, but as a separate service. So it's easier to scale. You can put it in containers. You can do whatever you want to make the ingestion pipeline stronger. You can also have your custom pipelines. And here you have a list also of all the features supported. So you have multiple vector storages, multiple content storage, and multiple orchestration layers, the queues I was mentioning before.
Nice.
All right, I think, this was quite another good episode. We are over 40 minutes, so we can wrap it up today. Maybe, so the next time, I think we can continue on these topics because they are really interesting. Maybe Marc can show us something about LangChain so that we can see a comparison with Semantic Kernel.
This means I need to improve my Python. Otherwise, the 20 viewers will be like, yeah, your Python code sucks. Yes.
I think they'll forgive you. So yeah, no worries.
All right. Yeah, sure. Let's do this. Although next Friday I won't be available for recording, unfortunately.
No, now we can resume at least the normal. So don't expect a new episode every week. So This time I admit it was easier because we already have the content. We decided just to split it into parts to make it easier. But unfortunately, we have a work also to do, so we can't spend the whole week preparing the content for these webinars. So.
Oh, well, we can, but then our managers are rather unhappy with our results at the end of the week.
Sometimes there is a good connection between the two, and we are able to leverage work stuff for these episodes, but not all the time, especially when it comes to the wildest experiments. So I forgot one other thing we can do is that again, we are out of time now, but I have also the wild experiment of running Semantic Kernel with open source LLMs running on your machine. So if we want, we can do another episode on this one. So.
Yeah, maybe we can just like split this one, and since I guess we skip the part because if we do LangChain, we probably, because I have a few thoughts on Semantic Kernel versus LangChain, and
this will give you more time to prepare. So I did it for you.
We're probably not preparing for a LangChain because I do have a few examples ready, but rather polishing my Python knowledge.
Become a Python master in 2 weeks. So.
Or so it also supports JavaScript, right? Like LangChain.
Yes, even if I have understood well, it's not coming from exactly the same team. So
no, but it's endorsed.
It's working on LangChain for JavaScript.
Yeah, it's similar to to semantic kernel with Python. Well, okay, so the Python part is coming from the semantic kernel team, but the thing is, it's like lagging behind always. Like,
yeah.
and
Yeah,
also all the
I think the
samples.
difference is that, as you said, in this case, both the Java and Python versions are living in the same repo, and they are part of the same team. They are owned by the same team. While with LangChain, from my understanding, the JavaScript version is totally different repo, totally different team, totally different project. Of course, connected and related to LangChain, but it's not like, I have another folder in the LangChain repo with the JavaScript project.
But at least they are like referring to, it's not like they are doing like, oh, no, we just do Python, there's nothing else. They even like, okay, there's also JavaScript, but keep in mind, it's not like, not all the examples work and there's different, but yeah.
That's good.
So it's not like the hidden stepbrother that lives in the basement, but it's, well, I mean, then again, it's JavaScript.
So we said it at the same time. Okay. We all love JavaScript, so.
No.
All right. So thank you very much for following us so far. So stay tuned for the next episode. Bye.
Thanks. Bye.